All right, let's take a look at question 4. It says the figure above shows the graph of f prime, the derivative of a twice differentiable function f on a closed interval, 0 x between 0 and 8. The graph of f prime has horizontal tangent lines at x equals 1, x equals 3, and x equals 5. The areas of the regions between between the graph of f prime and the x-axis are labeled in the figure. The function is defined for all real numbers and satisfies f of 8 equals 4. All right. All right. So this is the graph of f prime. And if you notice, the calibration on the x-axis is missing some numbers. They're included in the coordinates, but let's just put it here. So this is 2, 3, this is 4, 5, 6, 7, 8. Okay, so recall that the area underneath the curve can be found using the integral, and this is the function. This is the derivative function right here. Okay, f prime. So a part says find all values of x on the opening interval 0 less than x less than 8 for which the function has a local min. Justify your answer. So you have to remember that we're looking for the local mean here, so we do not consider endpoints. We're just looking at interior points, okay? So to find the local mean, let's just write down the formula real quick. F has a local mean at, let's say, some C in an open interval AB when F prime of C, where f prime changes from what? Changes from negative to positive, okay? And f prime of that C value is equal to 0, okay? So what do these two things tell us? F prime changing from negative to positive basically means that the function f was decreasing before, and then it starts increasing around C, okay? And then f prime of C equals 0 basically means that we have a critical point at that value, okay? All right, so what we're going to do is look at this function. This is a function of the derivative, and we're going to see look for the points where it changes from positive to negative. All right. So if you look at this graph, f prime, if it's in this half plane right here, it's positive, and if it's in this half plane down here, it's negative. Okay. So let's sign this function. In this region is positive, 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 and then down here it's negative. And then here it's positive. Okay, so where does it change from positive to negative? I mean, from negative to positive. You notice it changes from negative to positive at x equals 6, and the derivative f prime at that point is equal to 0. F prime of 6 is equal to 0. Okay, so let's write down the answer to part A. So we're going to say the function has a local mean at x equals 6. We're asked to justify our answer, right? Why do we know it has a local mean at f equals 6? At x equals 6 because f of x has a critical point at x equals 6. That's the first condition. Or basically we can say f prime of 6 is equal to 0. And we have a critical point that doesn't guarantee that it's a minimum, because you notice that we have critical points here and here too, right? In order for us to know for certainty that it's a minimum, there has to be a sign change in the derivative. So we're going to say and f prime of x changes from, it has to change from negative, which means that um, the function was decreasing, to positive, which means that the function was increasing afterwards. Okay, so that goes the answer. Now a distractor is some, might look at this graph and call this the minimum. This is the minimum of the derivative, but the problem asks for the minimum of the function. Okay, so we have to be really careful. All right, let's take a look at question B. We're asked to determine the absolute minimum of the function on the closed interval. So if you're looking for the absolute minimum, what you have to do is you must consider the endpoints and the critical points. Okay, so to find the absolute minimum, absolute min, we must compare endpoints and critical points. Okay, all right, so let's go ahead and take a look at them. So our endpoints are 0 and 8, so we have to find f of 0 and f of 8 because those are the endpoints, and then we also have to find f of the critical point. The only critical point we're going to consider is 6 because it's the only one that's a mean. This is another critical point, but it's not a mean, it's a maximum because it changed from increasing to decreasing. Okay, and this critical point right here, there's no sign change, so it's not an extrema. All right, so let's go ahead and find f0. But before we do that, let's do a real quick review on the fundamental theorem of calculus 2. So you remember this formula, f of b, the antiderivative at b minus the antiderivative at a is equal to the integral from a to b of f of x dx. Right? This formula is the same thing as saying f of b minus f of a is equal to the integral. Now the relationship between these two is if you differentiate f prime, uppercase f, you get f. Okay, basically this is the antiderivative of that. So f is the antiderivative of the derivative of f. So the integral from a to b of f prime of x dx. These two formulas mean exactly the same thing. Okay, it's basically, this is FTC part 2. And if you wanted to find f of b, so this formula basically implies that f of b can be found by computing f of a plus the integral from a to b of f prime of x dx. All right, so this is what we're going to be using to find the value of the function at some of the points that we're looking at. Okay, all right, so to find the local mean, we want to look at the endpoints and the critical points that can be classified as minimum. So for the first endpoint, we're going to start with 0. So f of 0, how can we find f of 0? Now one clue we know is that we know f of 8. In the problem we're told that f of 8 is equal to 4. So we can set up an integral that involves 0 and 8. Okay? So f of 0 is simply going to be f of 8 plus, since we're working with 0 and 8, we can find the integral from 0 to 8 of f of x, f prime of x dx. Okay? So why am I confident that I can find an integral from 0 to 8? Well, I'm confident because we're provided with the area underneath the derivative function for the entire interval, so I can find what the integral is on any interval that I want. All right? So let's go ahead and evaluate this. So f of 8, we were told initially in the problem that f of 8 is equal to 4. All right? So f of 8 is equal to 4. 4 plus, now let's see what the value of the integral is. Alright, just a quick correction here. I need to change my limits of integration. If you look at my formula here, whichever one comes first goes on top. So we have 0 and 8, so this is supposed to be 0 to 8. Okay, so we're going to be looking for the integral from 8 to 0 of this function right here. So since we wanna do it in order, so what we can do is we can use the order property of integrals to reorder this function, this integral expression, and we can write it as minus, we switch the limits of integration, 0 to 8 of f prime of x dx, okay? So you might, if you don't get this part, let me show you how it works real quick. Using FTC part 2, I can do the setup using this formula. This is just FYI. So if I wanted to compute f of 0 minus f of 8, this is the same thing as an integral from 8 to 0 of f prime of x dx. So what I did to come up with this expression is I added f of 8 to both sides. So you have f of 0 is equal to f of 8 plus this integral. Okay? So that's why the order is reversed, because I'm looking for f of 0. Okay, so to find out what the value of this expression is, all we just have to do is find the area underneath the curve for the entire domain. All right, so it's the area underneath the curve is simply going to be here is 2 plus 6, and then this one is downstairs, so it's minus 3 plus 7. Okay, so 2 plus 6 is 8. 8 minus 3 is 5. 5 plus 7 is 12. Okay, so the total area is basically 12, all right? So that means that this is going to be 4 plus negative 12, which is equal to negative 8. All right, so that is f of 0. Now we want to find, this is the endpoint. Let's indicate it here. Endpoint. And then now we want to, let's check the critical points. Okay, we have only one that qualifies as a minima here. So critical point is x equals 6, and endpoint was x equals 0. So let's evaluate the function at 6, or f of 6. All right, so to find f of 6, we can basically pick any function we want to start with. We can pick f of 1, 2, 3, 4, 5, 7, or 8. But whichever function we pick, we need to know the output value. All right? So which is the only output value I know from the problem? The only output value I know is 8, f of 8. So I'm basically constrained to selecting that, since that was the only viable option I have. Okay? So let me give you another scenario. Let's say I wanted to pick f of 2, for example. So f of 6 will be equal to f of 2 plus the integral from 2 to 6 of f prime of x dx. Now let's say I chose to select f of 2. So I can evaluate this with ease. Is basically figuring out the area from 2 to 6. Basically it's somewhat complicated because we don't have a nice area here. Even to make matters worse is that we do not even know what f of 2 is. Alright, so we have to be really strategic in our selection here. So the only thing that is practical here, that we know the output value of the function and the area underneath the function nicely, is 8. So we have to use f of 8. Okay, f of 8 plus the integral, since 6 comes first, from the integral from 8 to 6, integral from 8 to 6 of f prime of x dx. Alright, so we already know what f of 8 is. F of 8 is 4, plus the integral from 6. Well, we got to reverse this again because of the limits of integration are not in order, so we reverse it. So minus integral from 6 to 8 of f prime of x dx. Now this expression, basically we are looking for the area underneath the curve from 6 to 8. Okay, so we have 4 minus So from 6 to 8, there's this nice area right here. From 6 to 8 is basically 7. All right. So it's going to be 4 minus 7. And your final answer is negative 3. So we see that this is smaller than, I'm sorry, this is smaller than that. We're looking for the smallest. So let's check the other endpoint. We have two endpoints, 0 and 8. So let's look for f of 8. What is f of 8? F of 8, we already know what this is. We're told that it's 4. You don't need any fancy calculus to figure this out. So what is the absolute minimum? The absolute minimum is the smallest number out of all three, and negative 8 is the smallest. So the absolute minimum of f is negative 8. Okay? And it happens when x equals 0. So this is the absolute minimum. All right, let's take a look at the next question. All right, so part C says, what interval from 0 to 8 is a graph of f both concave down and increasing? Explain your reasoning. Okay, so what I'm going to do is I'm going to make a little mnemonic device to help you remember the connection between f prime, and f double prime. All right, so this is portion C. So let's say we have three functions. We have f, and we have f prime, and we have f double prime. Okay? All right, so if we're looking at these continual derivatives right here, we can take either one step back or two steps back. Okay, so this can be considered one step back, and this is another one step back, or we can have two steps back from f double prime all the way to f prime. So looks all the way to f, looks like a heart. Okay, so we have plus or minus. So plus, taking a step back, you can either use plus to take a step back, or you can use minus. Basically, the sign of f double prime and the sign of f prime can tell us about the function before it. All right, so we can look at f double prime plus or minus, or f prime plus or minus. Now, when you're taking just a step back, that tells you if the function stepping back is either increasing or decreasing. Okay, and I take another step back, the function before it is either increasing or decreasing, or it's antiderivative. So if f prime is positive, that means f is increasing. If f prime is negative, that means it's decreasing f. All right. If f double prime is positive, that means f prime is increasing. And if f double prime is negative, that means f prime is decreasing. Okay. When you're taking two steps back, basically integrating twice, that tells us about concavity. Is it concave up or concave down? So if f double prime is positive, f is concave up. If f double prime is negative, f is concave down. All right? Just a little device to help you connect the signs of derivatives and their antiderivatives. All right. So we're asked to find where f is concave down, and increasing. Okay. All right, so to answer this, we're going to split it into two parts. We're going to deal with concavity first, and then we'll deal with the increasing part, okay? So if f is concave down, that implies that, see this connection between f and f double prime? If f is concave down, then f double prime is negative, okay? F double prime is negative, and if f double prime is negative, we can use our step back here. F double prime is negative, that means f prime is increasing. Okay? So that means f prime is increasing. Alright, remember the sign tells you if the function taking a step back is increasing or decreasing. Okay, so this is the first condition. We have to look for where f prime is increasing, since we're given the graph of f. Now if f is increasing, f is increasing, what does that tell us about f prime? It tells us that f prime is positive. So if f is increasing, f prime is positive. So any interval where f prime is increasing and positive, then we will conclude that the function f is concave down and increasing on that interval. All right. So where is f prime positive and where is it positive and increasing? It's positive and increasing. Let me check it again. It's an increasing we have. Oh, I made a mistake here. If f double prime is negative, then f prime is decreasing. So negative means decreasing. All right, so we need to look for where f prime is decreasing and where f prime is positive. So positive and decreasing, that's what we need. All right, let's go ahead and find it out. So where is it decreasing and positive? It's decreasing from 3 to 4, decreasing and positive, and decreasing and positive from 0 to 1. Okay, so let's write down what that means. Our conclusion, we're going to say that f is concave down and increasing on 0 to 1, union 3 to 4. Why? Because of the information that we were able to find out concerning f prime, because f prime is decreasing. We know that it's decreasing because f was concave down, which means f double prime is negative. And going back, we know that f prime is decreasing because f prime is decreasing and positive. Okay, since f is positive, we know that f prime has to be, since f is increasing, we know that f prime has to be positive. All right, so these two can help us come to this conclusion. Now let's take a look at the last question, option letter D. We're asked to find the slope of the tangent line at x equals 3. So slope of the tangent line at x equals 3 is basically another word for expressing the derivative. We're supposed to find g prime of 3. Okay, so how do we do it? First of all, we have to find g prime of x, and then we're going to substitute. All right, so we know that g of x is equal to f of x, the entire function raised to the third power. So how do we find the derivative of this function? This is a composite function. So when you find the derivative of composite functions, you use the chain rule, right? So if you have let's say g of x is equal to f of u. Okay, f of u of x. The chain rule requires you to differentiate the outer function, holding the inner fixed, times the derivative of the inner function. Okay, so this is basically the chain rule. So let's apply that here. G prime of x equals, now this can be viewed as u to the third power, where this inner function f of x is u. Okay, so when you apply the power rule to the outer function, if you differentiate this function prime is basically 3u squared times u prime. Okay, so let's go ahead and write that down. So if you differentiate the outermost function, you're going to have 3 times f of x. Using the power rule, you bring down the exponent and then you subtract 1 squared times the derivative of u. U prime is f of x. U is f of x, so u prime is going to be times f prime of x. Okay, now let's evaluate this derivative at x equals 3. So we're going to do g prime of 3 is equal to 3 times f of 3 square times f prime of 3. And we were told earlier that f of 3 is negative 5 over 2, so we're going to plug that in here for f of 3. So this is going to become 3 times negative 5 over 2 quantity square times f prime of 3. What is f prime of 3? We have the graph of the derivative, right? So we just evaluate this function at x equals 3. F prime of 3 is equal to 4. All right, so let's put that in. And that's going to give us times 4. All right, and if we work this out, we have 3 times 25 over 4 times 4. The 4's cancel out. 3 times 25 is equal to 75. All right, so that's that.